Atlantis, during the entire flight, had virtually no electrical or mechanical problems, which was a joy for the crew because we could spend more time getting the useful things done and looking out the window.
So what were some of the most innovative things on the space shuttle?
Innovative, wings to start with. The earliest manned or piloted spacecraft was a capsule. So wings was a very innovative approach to space travel, not only launching to space, but also returning to Earth. And the wings were only useful on the return to Earth. Another innovation was this Canadian-provided robotic arm. It was an international project, very useful, including on my flight on Atlantis, in which two of our crew members did a unique spacewalk to demonstrate construction in space.
So what would you say the training was like to become an astronaut?
To work inside a spacecraft in orbit takes certain necessary skills and personal characteristics. For instance, you had to go through a screening process before you even went into training for the managers to determine that you weren't claustrophobic. You can't be afraid of small spaces in a spacecraft because you can't open the door and get out. And the training then included a lot of course, systems training. Now, I didn't need to learn every system in there. The mission specialists knew how to operate every orbital system with the spacecraft while it's in orbit. The pilots fly it up and fly it back home, and they didn't teach me to do that. That was fine. I was a payload specialist. And then, of course, I had to be very trained up on my particular research, as well as learning to work with my fellow crew members. That took well over a year.
What lessons did we learn from the shuttle program that we're applying to the future of spaceflight?
The space shuttle was the first to utilize in that capacity solid propellant first stage booster rockets. We learned lots of lessons from using those booster rockets to launch shuttles into space. And solid rocket boosters are planned and are in development and testing right now for use in the next big NASA launch vehicle, the Space Launch System. And the engines on the space shuttle, they're being modified for use on that next big launch system as well. But also learning to train efficiently and effectively crews to work together, that was an important lesson that's being used in the future. The overall efficient technology that was used to control, to do life support onboard space shuttle. So all of those things, those are what comes immediately to mind as lessons learned from space shuttle for future space activities.
Well, thank you so much for taking the time to talk to me today.
My pleasure.
Thanks to the shuttle program, NASA was able to set its sights, with the help of the rest of the world's space community, on an even greater goal: the world's first long-term home in outer space, the International Space Station. NASA, along with Russia, Japan, the European Space Agency, and Canada, slowly constructed the International Space Station for nearly a decade and a half, from 1998 to 2011, the same year NASA finally ended the shuttle program.
The ISS is a major achievement of human ingenuity and science, and as of today has housed more than 236 people from 18 countries. Truly a space station serving all of humankind.
Thanks to the countless experiments that can only be studied in low Earth orbit, amazing advancements have been made. But none of those experiments could ever have gotten off the ground without the help of an amazing support team in the Rocket City.
We're standing outside the Payload Operations Integration Center at the Marshall Space Flight Center. This is the primary Space Station Science Command Post, and it is here that all of the International Space Station science experiments are coordinated. I'm joined now by Payload Operations Director Christy Robertson. Thank you so much for joining us today.
Thank you. It's good to be here.
So why is this called the Payload Operations Integration Center? What exactly is a payload?
So a payload is the experiment itself. So each experiment that a scientist launches to station is called a payload.
What happens on a typical day in the Payload Operations Integration Center?
7 days a week, 24 hours a day. Typical day begins with a crew wake. Throughout the day, our job here at the POIC is to interface with the crew for their science experiments to ensure that those experiments are executed and be kind of the liaison between them and the payload developer that actually developed the science experiment.
So what do you guys do to help the astronauts in space doing these experiments?
When they have questions or issues, anomalies, they'll call down to POIC, and then we work to get them an answer and a resolution so that they can proceed through their experiment.
What sorts of scientific fields are researched up there?
So we have everything from combustion to rodent research. We also have various life sciences, human research sciences that are done. So many of the astronauts participate in what we call human research experiments, which are those things that evaluate essentially the toll that space takes on a human body.
How does the payload operation team prepare for a scientific expedition?
So we start about 1.5 years out preparing for each expedition. And part of what we do is actually some on-hands training. So we have a center downstairs that I can take you and show you, and we can kind of see some of the on-hands training that we get.
Okay, cool.
One of the things we have for our controllers here to be able to utilize when they're developing procedures as well as getting ready for operations are our hands-on environment. This is the lab that we're currently in. It is a true to life-size mock-up of the lab that is on space station, so the U.S. laboratory. So one of the racks that we have there is this one, which is the MSG, which is a microgravity science glove box. So as you can see, the work volume will extend. That just allows the crew members more functionality. So if you want to, you can go ahead and stick your hands in there, see what it would feel like to have a glove on, and see what adjustments you can make. Create a pressure right here for you. So you should see these other gloves kind of fill up around you.
Thank you so much for teaching me all this stuff. I really enjoyed it.
Thank you, and thank you for your time.